Back to our implicit derivation examples. It's a mouthful. So it's kind of hard to say. Cut me some slack there. I'm doing the best I can. When you're doing this, you'll notice I put a tiny little dot there. Normally in algebra that means multiplication. So I bet we're going to use the product rule there. Please be careful when you do these. So I'm going to take the derivative of x squared times y plus the derivative of just plain old y times x squared. That's just the derivative for that portion. Now for the remainder of this problem, I get 12y dy dx minus 2 dx dx. I'm not writing that down. Dx over dx is kind of a waste of your time and mine. And so now we've got these different terms here. As a matter of fact, we have 4 terms, don't we? And I could take the parentheses away. I was just showing that was all part of that top part there, that product rule. But there's 1, 2, 3, 4 terms. It's all algebra. Finding out what dy dx is equal to is simply solving for dy dx. Once again, the steps are this. Take every term that has dy dx and put it on one side of the equation. I don't care if they're both on the left or they're both on the right, but put them all on one side. Now take all the terms that don't have a dy dx and move them to the other side. So I move everything without to the right, everything with a dy dx to the left. This little trick is so simple. You've probably done it with some problems. How can I solve for dy dx here? Simple. Factor it out of both terms. It's so easy. So easy once you've done it once or twice. First time it's probably difficult to think of. But yeah, that should give us the answer. At that point, you know what to do. Just divide over all the stuff over top of the stuff and mix a little of this and a little bit of that. But the real trick is separate. I'm not promoting segregation here, except dy dx. Segregate all the dy dx's away from all the other terms. Factor out dy dx and divide. That's going to help us along our way. We need to take a look at this third example before we run out of time. For the non-linear sort of people, you might like this. The rest of you are going to hate me. Thank you. I'm going to take the derivative. I'm going to work from the bottom of the page up to the top. Please don't try this at home. I am a professional. I have a safety net right below me. You just can't see it. What special derivative rule will we need to use here if I am taking the derivative with respect to x? What is it that I need to do? I know, the derivative of y is easy, the derivative of 2 is easy. But the special rule I need here is the chain rule. I have one function inside of another. Now, there's no elegant way of doing this. You might have to just stop and say, wow, this is like the square root of something, and then that square root is x times y. You might need to find a little space somewhere else to do part of this problem. But then I do the chain rule. I take the derivatives of each term. Let's see, oh my gosh, that's a product rule again. 1 times y plus the derivative of y times x. And then I combine them. So, in other words, what I'm saying, no easy way of doing this. Absolutely nothing that's going to be easy about this. Oh, goodness gracious. Multiply these two derivatives together, 1 times y plus x times dy dx. Pretty miserable, but it happens. So you have to check and make sure that had a chain and a product rule. Simplifying, you might have to multiply across like this. I distributed that across, and yes, I rewrote this as square root of xy. Then I can separate terms and solve. All my dy dx terms are on the left. I factored out, and then I divided both sides. Even simplifying.